This is section 9.3, composite figures. Objectives: use the area addition postulate to find the areas of composite figures. Just in case you forgot, the area addition postulate you saw in section 9.1. The second objective is use composite figures to estimate the areas of irregular shapes. Vocabulary: composite figure. Here's problem number 1. It says find the shaded area of the composite figure. Round the answer to the nearest tenth if necessary. Notice that this is what we call composite figure. The way that you're going to compute the area is you're going to do the following trick. All I'm going to do is I'm going to take this portion of the picture and then I'm just going to transfer it to here, and you should be able to see that this represents now a rectangle with base 3 and height 2 inches. From here I apply the formula based on its height, 3 times 2, and the answer is 6 square inches. Let's go to number 2. Same directions. So now you have another composite figure here. The way that you're going to approach this problem, you're going to compute the area of 2 rectangles. What do I mean by that? This is what we're going to be doing. First, understand that this is 81 millimeters. How do I get 81? All I'm doing is I'm taking 36, 27, and 18, and this is how I get 81. So I'm going to find the area of this rectangle. Once I do that, this is what I get. The area of the large rectangle is base times height, 81 times 54, and this is the number that you get after you do that product. Then I'm going to find the area of the small rectangle, which is this rectangle here. So all I need to do is take the base and the height, find the product, and this is what I get. At this point, to find the area of the shaded portion, I am going to do the following. I'm going to take the area of the large figure, which is the rectangle, and subtract the area of the small rectangle. Once I do that, this is my answer. 3,888 square millimeters. Let's go to number 3. So here's number 3, same directions as the previous 2 problems. So what we need to do is we need to find the area of this. Let me get a pen. This region, and so forth. So the way that we're going to do this, we're going to find the area of 2 shapes, and then I'm going to subtract them. So the first shape is basically a circle. Notice that this circle has radius 1. Formula is pi r squared. That's why I have this. The radius was 1. Now I'm going to find the area of this square, but I'm not going to look at it as a square. I'm actually going to look at this as a rhombus. And notice, if I was to continue here, I know that this is also 1 because of the radius, and this diagonal is 2. In the same manner, I can go from here to here, and I have diagonal 2, which is also a distance of 2 units. So at this point, I apply the formula to find the area of a rhombus. I substitute diagonal 1, diagonal 2 times a half, and this is my answer. And then at this point, I am going to subtract these 2 areas, circle minus the rhombus, round to the nearest tenth, and I get 1.1 square units. Let's go to number 4. Slightly different problems. Let's find the area of the shape. Round your answer to the nearest hundredth. So what we're going to do is I am actually going to break this up. This is what we call composite figure. First, I'm going to find the area of the square, which again you should see it, which is this. So I get 9. Then what I'm going to do is I'm going to put these 2 shapes together, and it actually makes a circle. So then I find the area of the circle. The radius is actually half this side, which is 3 inches. So that's why I have 1.5. Punch this into the calculator and I leave it in terms of pi. And then in this case, since I have these 2 areas, I'm going to add them. I'm not going to subtract. And once I do that and round to the nearest hundredth, this is the answer that I get, 16.07 square inches. Let's go to the next slide. Says use a composite figure to estimate the shaded area. the grid has squares with side lengths of 1 feet. So in other words, if the area of this square is 1 square foot. So I want to find the area of this shape. So then I break it up the following way. I'm going to be looking at this square, and what I'm doing here, I am going to take this portion of the figure and I'm going to put it in here. And notice that once I do that, I have a 3 by 3 square. Remember, we're estimating. That's why the area of that square is 9 square feet. Then I find the area of this shape, which looks like a rectangle. I can approximate this shape and make it look like a rectangle. And I get base and side, which is 3 times 1, 3 square feet. Then this remaining shape here looks like a triangle. So then I use the area of the triangle formula. Base times height, the base is 3, the height is 1, and I get 1.5. To a good estimate of this composite fit using composite figures is adding these 3 numbers that you see here, and this is why the answer is approximately 13.5 square feet. Let's go to the next slide. Same as number 5, part A says use composite figures. Here we go, let's do this. I'm going to be working with these shapes. This, let me get a pen here. What I'm going to do is I'm going to take this shape here, which is a triangle, and I'm going to put it over here. Once I do that, it's no longer here, and I have a square, which is the area of this square is 4. So I have 4. Then I look at this, which looks like a triangle. The base is 2, the height is 1. If I apply the formula, base 2, height 1 divided by 2 or multiply by half, I end up with 1. So I have 4 plus 1. That's why the area of this figure is about 5 square feet. B looks a little bit different, but again, we're going to be using composite figures. First, I draw square. So I know that this is 4. Then this, excuse me, this is a trapezoid. Or notice that this is 1 unit and this is like a half of the square. So the area of this is 1.5 square feet. So let me just cross this out and I'm going to use 1.5. Then I'm going to take this shape and this shape and I'm going to combine them. So I'm going to cross this one out and I actually get a rectangle. And notice base and height, so this is 2. Finally, I have a triangle here, base, which is 3, the height, which is 1, so 3 times 1 divided by 2, so this is approximately 1.5. I add these numbers, this is 6, this is 3, so the area is about 9 square feet. You can break it up differently, and your area should be pretty close to the numbers that I have here. Let's go to the last problem. Here's number 7. It says Mike is remodeling his kitchen. The countertop he wants costs $2.70 per square foot. How much will Mike have to spend on his remodeling project? So this is what we're going to do. First, you should agree with me that the area of this portion of the countertop, let me get a pen, right here, is 12. Why? 2 times 6 is 12. What about this one? Also 12. So how much area do we have in this countertop? Square footage is actually 24. 12 plus 12 square feet. They're telling me that this is the price per square foot. So what am I going to have to do to find how much Mike has to spend? Multiply 24 times 270, and this is how much money he has to spend on this countertop. This is the end of the video. Goodbye.